Let's say that you're going for a nice scuba dive out in the North Pacific Ocean, and by a series of unfortunate, and admittedly very unlikely events, you find yourself at the bottom of the Mariana Trench. The Mariana Trench is where the Pacific Plate is being subducted by the Mariana Plate, causing the deepest trench in the world's oceans. If you're unlucky enough to find yourself at the bottom of the Challenger Deep, the deepest section of the Mariana Trench, then you're in trouble. This is because the Challenger Deep has a maximum known depth of 10.9 kilometres, which results in a pretty decent pressure of 108.6 megapascals, over 1,000 times atmospheric pressure. Fortunately, a man named Daniel Bernoulli may come to your rescue with an equation.
Bernoulli's principle states that increasing the velocity of a fluid will decrease the pressure or the fluid's potential energy. This can be expressed as such: 1/2 rho v squared plus rho gz plus p equals a constant, where rho is the density of the fluid, v is the velocity, g is the acceleration due to gravity, z is the elevation, and p is the pressure. V equals 0, so we are left with 1050 gz plus 108.6 times 10 to the 6 equals constant. To get v squared, we first can cancel the 1050 gz, since we subtract 1.09 times 10 to the 6 from both sides, multiply both sides by 2, and then divide all by 1050. To finish off, we square root this to get the velocity,
which is 452.5 metres per second, which, to put it in something you can relate to, 1,629 kilometres an hour. To put this into perspective, the fastest submarine was recorded at just over 80 kilometres an hour. The fastest torpedoes have not officially exceeded 400 kilometres an hour, and even on the surface, the world speed record is 511 kilometres an hour. The Thrust SSC has the world land speed record at 1,228 kilometres an hour, still not up to the 1,600 required for this speed of water. If you were unable to hold on to anything, you would travel the entire 11-kilometre section of the Challenger Deep in just 24 seconds. Even if you could cling onto the seabed, the water would exert over 5.2 meganewtons of drag force on you, which is equivalent to 3 blue whales.
And if you dislike the imperial measurement, that's 10 sperm whales.
Thanks, Will. This huge force would accelerate you from 0 to 100 kilometres an hour in just 0.4 milliseconds, exerting you to a maximum g-force of 7,622. That's much higher than the highest g-force ever survived by a human at just 214. So, with all this in mind, it's fair to say increasing the speed of the water isn't going to help you survive at the bottom of the Mariana Trench. There is good news though. Some mechanical watches may survive this G-force, so that's good, because it's probably not covered under warranty.